In this video, I'm going to discuss the condition states for the material type steel. Now, steel is prevalent throughout our bridges. Next to concrete, it's probably the second most prevalent, and a continuous steel beam structure is the most prevalent structure type on our national highway system for the superstructure. So steel is worth taking a little bit of time and understanding the condition states. This is a continuous steel beam bridge, and this guidance is directly related to the primary elements and the secondary elements. So you have one chart or one guidance for everything that's steel, and then once you start thinking about everything that's steel, it's your 836, it's your 588, it's your beams, your cross frames. For your trusses, it's your floor system, including your stringers, your longitudinal elements, your floor beams, your transverse elements, your lower chord, your upper chord, diagonals, gusset plates, verticals. It's your axial, it's your bending steel elements, your cross girders or pier caps that are steel, anything that's steel, including substructure units, especially those substructure units that don't have reinforcement inside the column. Those would be rated as steel. So your steel bents, whether they're sheathed or whether they have, whether they're the H-pile. Once you start thinking more about steel and metal, this guidance is the best guidance for the metal that we have, the corrugated metal pipes, steel, and even our deep beam rails, our guard rails. That is steel. This is another look at the back side. Now all of these elements you'll note from the field report have a dedicated or have a specific quantity, whether it be one of the 3 linear feet, square feet, or each. Those are one of the 3 options. So for example, guardrail would be linear feet. So each foot, as you move along the guardrail, that quantity goes into one of the condition states. Here's the condition states. You're given 4 buckets, so to speak, and looking at this chart, we take your defects on the left-hand side and we move from the left to the right-hand side, from good to fair to poor to severe. And for the purposes of this guidance, I'm going to start with each defect in condition state 3 and explain how quantities can scatter to condition state 2 and or condition state 4, and in some cases quantities can go to 4, but then an analysis can prove otherwise, and an analysis can justify keeping that quantity in state 3. So first and foremost, our first, probably most prevalent defect within our steel is section loss, and that's when the thickness of the steel is reduced, whether it be pitting or something more advanced where there's a corrosion hole. By and large, if there's section loss, it's going to reside in state 3. Most of our section loss will be in condition state 3. Now we talk about section loss, a really very, again, a prevalent location is at the beam ends underneath a sliding plate expansion joint or a joint with the seal that has failed and years and years of salt and moisture and corrosion. And then sometimes we'll go in and paint over. And this is a section loss to the web, and an inspector would say this is 3 linear feet because the beams, girders, are quantified in linear feet. So that means you're taking, from the end in this case, you're taking a vertical linear foot, and that linear foot includes the web and the flanges, each vertical foot. So if you have in this three-dimensional slice of your web flange combination, if you have any section loss, start with condition state 3. That's usually where it will reside. This is state 3. And something where there's not loss, but there is surface corrosion, that's going to be condition state 2. That's how it scatters to the fair side. And there is some overlap when we start talking about corrosion and placing those quantities within condition state 2 for our steel, because there's a second item for our primary steel protective coating system, and we're also very interested in how that steel is being protectively coated. And you'll notice that there is a specific row or defect description for protective coating system. This is another element entirely, but I just wanted to show you the overlap. We're concerned with more things with protective coating. For example, how light or how large the areas of corrosion are, if there's heavy or laminating corrosion, if there's peeling of the top coat or initiated cracking in the protective coating system, or the discoloration within the weathering steel. There is some overlap. So if you have corrosion controlling your steel and a lot of quantity is in condition state 2, that should also be reflected within the appropriate condition state for protective coating system as well. There is some overlap. So going back to steel, section loss, corrosion holes, some section loss, the inspector may want to push that quantity into state 4. You should dump it into 4, but an analysis can move it back. So for example, the bridge on the left-hand side, that's a vertical with a corrosion hole, and that would be the vertical is each, so that one vertical, that whole vertical was in condition state 4 temporarily. We did an analysis within a 90-day window of the review period, and the analysis said that there was no impact to capacity. So we moved this vertical back to condition state 3, and then the reviewer approved the final report. So all that happened within that 90-day window. The example on the right-hand side, after we removed a lot of the pack rust and the section loss, this resulted in an emergency repair. So this one stayed in condition state 4. So once you dump something into condition state 4, there will be a lot of attention focused on what quantity, and there would be an analysis. So there is action required when inspectors code something in condition state 4. But just know that there is movement allowed after an analysis can prove otherwise. So this is an example of painted over section loss that would start in 4, and structural analysis could move it back to state 3 depending. Cracking is the second defect I want to talk about, and cracking, I put compression. You know, if you think about your distortion cracks, where the cracks initiate at the top, you know, between that top flange and the connection of the vertical stiffener, where you see those web gap cracks, that would be an example of a crack that would start in condition state 3. And this is an example. This linear foot of the beam would be in condition state 3. And if it's fixed, it can be moved up to condition state 2. And once the steel is cracked, the highest it can then go is condition state 2. Certainly a cracked tack weld that has not gone through the base metal, and you still have full connection, you've got your rivets and bolts fully connected, and this is just all cracked all the way through. This would be an example of a condition state 1 crack, one that we're not concerned about. Now you do have cracks in the tension zones. Um, Condition state 4 is the place those should go. And again, an analysis can prove otherwise, but largely those would likely stay in 4 until a repair was made. Whether the crack is all the way through the beam, eliminating that load path, or in the tension zone, those are going to go into condition state 4. There is guidance within the manual that says anything longer than 2 inches, 2-inch crack should go into condition state 4. That means those should be analyzed to see if that does reduce the capacity or have an impact on capacity, and those can move up to 3 after an analysis. The third defect would be connection, and think of loose bolts or missing bolts, missing rivets, or even pack rust. There's a distinction in the manual that we say pack rust with distortion and pack rust without distortion. The pack rust that is initiated, you can see corrosion bleeding through, where there's no distortion, place those in condition state 2. If there is distortion, leave those in condition state 3. The photo on the bottom right would be with distortion. You can see the wavy top plate. Condition state 4, again, if there's a crack in the connection or missing bolts, missing rivets, that's when you'd see your condition state 4. Largely, unless it's really obvious, pack rust would likely stop with condition state 3. So on your left-hand side, you got your photo with some distortion at the splice. This would be one where you could make an argument where this would be condition state 4, depending on the capacity, the importance of that top plate. And just more examples of pack rust. We see lots and lots of pack rust. This would be an example of a condition state 4 connection. You've got severed bolts or the bolts working themselves out, increasing the diameter of the hole, obvious movement. Fourth defect would be distortion, and distortion should stay in state 3, and the distortion that, based off inspector experience, can be in condition state 4. Depends on if you want the attention, you want the analysis to verify what state this distortion should be in. So analysis could prove otherwise. So examples of distortion, structural distortions, when you see buckling or movement. Certainly gusset plates where we see distortion between the unbraced lengths. Those would be condition state 3 or 4. Buckled flange, broken web stiffeners, these are examples of condition state 4. Another defect would be damage. We see a lot of damage of our steel beams over an interstate or over a route, over a highway, and that linear foot would be placed in condition state 3 or 4. The guidance that we have in the manual is where you have that sweep more than 2 inches is going to push you into state 4, and it's going to beg for an analysis. If and when quantities are placed in 4 and an analysis proves otherwise and they move back to state 3, the inspector must clearly communicate that within the inspection notes, so the next inspector does not go through the same exercise where they move the quantities back and forth and analysis has already proved otherwise. Now certainly if there's change or if the crack is lengthened or if the distortion has increased, then they can go back to 4 and the analysis can keep checking to find the threshold where it's going to stay in the state 4. So this would be damage, your overheight hits. Lastly, your settlement and scour, the guidance for settlement and scour. This would be for steel elements that have settled or steel elements that are have scour, and dormant, repaired settlement or scour should be condition state 2. Signs of continuing unrepaired settlement or scour should be 3, and then anything that is extreme or changing abruptly, those are going to be your condition state 4 items.